Your Rancher server will be reachable at some hostname that you choose. The IP address that you attach to this hostname must be reachable by downstream clusters. Also, although it's theoretically possible to change this hostname after installation, doing so creates instability in the environment. It's far better to choose a name like rancher.mydomain.com and then just keep that hostname for the life of the environment.
We've already shown you how to deploy an RKE cluster, and in that section we discussed how RKE's flexibility means that you can deploy a single node cluster and later add more nodes to make it HA. Installing Rancher into a Kubernetes environment has more steps than the Docker container method, but if you're considering using Rancher in production and want to have the most options available for using it in the future, you can follow all the steps here, but with a single node RKE cluster. It won't be highly available, but you can convert it later.
Even with a multi-node RKE cluster, you'll be accessing the Rancher server via a single URL. The ingress controller will listen on all nodes in the cluster, so deploy a load balancer to receive traffic for your chosen hostname and then route that traffic to the hosts in the cluster. This could be a hardware load balancer, a cloud load balancer like an ELB or an NLB, or a software load balancer like Nginx or HA Proxy.
But no matter which solution you choose, operate the load balancer at layer 4 only, passing TCP directly through 80 and 443. Don't configure the load balancer at layer 7 for HTTP and HTTPS.
Don't do that.
Don't do that.
Don't. It is possible to configure TLS termination on the load balancer and then communicate between the load balancer and the Rancher server over an unencrypted connection on port 80. But we don't recommend that you do that either. If you really need this kind of configuration, you can find more information on how to do it in the documentation.
The load balancer you create will be dedicated to the Rancher server cluster, and that cluster will appear inside of Rancher as the local cluster. Workloads other than Rancher should never be run on the local cluster. So each downstream Kubernetes cluster that Rancher manages is going to need its own load balancer.
After you deploy the load balancer, configure DNS to point the Rancher server's hostname to the addresses or hostnames of the load balancer according to the instructions for the architecture that you choose. If your cluster is located on premises or in an environment where you can dynamically attach multiple IP addresses to a node, you can look at MetalLB as an option for running the load balancer inside of the local cluster. MetalLB enables a load balancer service on the cluster and assigns a dedicated IP to that service. The service sits in front of the ingress controller and passes traffic to the ingress controller in the same way that an external load balancer would. This deployment requires that you deploy RKE without the default Nginx load balancer, and then deploy MetalLB, and then deploy the Nginx load balancer from Helm and configure it to use a load balancer service instead of a node port service.
Rancher is installed with Helm, the package manager for Kubernetes. Our instructions are for Helm 3, the latest version of Helm at the time we're filming this. If you need to use Helm 2, those instructions are available in the documentation. Every one of these steps takes place on the system where you ran RKE up to install RKE, and where you have the configuration file for kubectl. Install Helm and verify you're pointed at the correct cluster by running kubectl get nodes before continuing.
Oh yeah, you don't want to run this on the wrong cluster. Ask us how we know.
Rancher requires Helm 3 to install its packages into a Kubernetes cluster. I'll need to add the Rancher stable Helm repository and fetch the latest charts from this repo before I can start installing Rancher in a cluster.
Right. With Helm installed and tested, the next step is to add the Helm chart repository. Rancher provides 3 repositories for Helm charts. Latest is recommended for trying out the newest features. It's not recommended for production. Now, these are features that are released, but not yet stable. Stable actually is recommended for production. These are releases that have had a little bit of time to bake and had any unexpected bugs worked out. The third option is alpha. Alpha contains experimental previews of upcoming releases. This is definitely not recommended.
Definitely not.
For production.
Definitely not. If you use an alpha release, there's no support for upgrading to, from, or between releases. Alpha releases are designed to be viewed and then deleted.
When you've decided which repository you want to use, add it to your Helm repository list.
We're going to install Rancher into the cattle system namespace, but we have to create the namespace before we can install the Helm chart.
Helm 3 requires any namespaces it installs packages in to exist before running the installation. I have an RKE cluster stood up for this installation, And here you can see I've pointed my kubeconfig to this cluster. The cattle system namespace doesn't exist yet, so I'll create it. Now that this namespace exists, the Helm installation will be successful.
Now we have to choose our SSL configuration. Rancher is going to be protected by TLS, so you have to pick from 3 options for how to provision this piece. The first is to use Rancher-generated self-signed certificates. The second is to use real certificates from Let's Encrypt. And the third is to use certificates that you provide yourself. Those could be real or self-signed. The first 2 options require a Kubernetes package called Cert Manager. This handles the certificate generation and renewal from external sources. We'll show you how to set that up now, but if you're using your own certificates, you can skip to the next part. Cert Manager is under active development by a company called JetStack, so the best instructions for installing it are always going to be from their documentation. We'll still demo the installation here because we're going to use Let's Encrypt as our certificate provider in a later step, though.
Rancher uses Cert Manager to automatically manage SSL certificates when using its own CA to create server certs. Installation of Cert Manager is easy. Apply the all-in-one Cert Manager manifest for the version required by your chosen version of Rancher, and all namespaces and components will be stood up. Wait for all of the created deployments to finish by using the rollout status command. Rancher won't provision successfully unless all of them are ready. Now that all deployments are ready, we can move on to actually installing Rancher.
Now we're ready to install Rancher. Depending on our TLS options, we might need to pass some additional flags to the installation command so that it knows what to do.
Let's show them first how to install the easy way.
Which way is the easy way?
Well, the one where Rancher generates self-signed certificates for you.
Yes. That's the default option when installing Rancher, and it actually doesn't require any additional configuration. You only need to specify the namespace and the host name when you do the installation. This installation option requires 2 parameters. We set hostname to the hostname that we're using for the Rancher server, and we use --namespace cattle system to tell Helm where to install the package.
We're finally ready to install Rancher into our cluster using Rancher-generated certs. Run the Helm install command specifying your chosen version of Rancher, passing in the required hostname argument. Use a rollout status command to wait for the server's deployment to be ready. It may take just a minute to wrap up. Once that's rolled out, you can perform first-time initialization of Rancher only after acknowledging any warnings about self-signed certificates. The default Rancher server configuration uses its own CA as you see. First-time configuration includes setting the admin password, confirming the server's URL is accurate, and configuring telemetry. Finally, in this version, the local cluster is listed as unhealthy because of a small bug. Just go into the cluster's edit screen and click Save to make it healthy.
Now for an installation that uses Let's Encrypt. To request a certificate from them, your load balancer and hostname should already be configured. Let's Encrypt will issue a series of HTTP 01 challenges that a Cert Manager will process. Cert Manager will automatically renew the certificates issued by Let's Encrypt before their expiration date. In addition to the parameters listed in the previous installation option, this installation method requires 2 additional parameters. We set ingress.tls.source to Let's Encrypt, and we set let'sencrypt.email to your contact email address.
Let's Encrypt uses the email to communicate with you about any issues with the certificate, such as its upcoming expiration date if for some reason it wasn't renewed automatically. This is a free service, so please respect them and use a real email address for this parameter.
If you want to have SSL certificates that provide public trust, then you'll probably choose to install Rancher using its Let's Encrypt integration. Cert Manager needs to be installed for this configuration too. Specify the Helm value for ingress.tls.source and let'sencrypt.email. Use your own email to get any notifications about your cert status from Let's Encrypt. This isn't used by Rancher for any other purpose. You'll see that after we've waited for the server to be up, as SSL certificates have been issued by Let's Encrypt and are trusted by default.
Finally, if you have your own certificates, either from a public or a private CA, you'll load these into a Kubernetes secret and tell Rancher and the ingress controller to use that secret to provision TLS. So in addition to the parameters listed in the first installation option, this method requires that you set ingress.tls.source to secret, and if your certificates are signed by a private CA, or if they're self-signed, which is effectively the same thing, you'll also need to set private CA to true.
Finally, if you want to use your own server certificates and possibly your own certificate authority, you'll need to tell Rancher about this configuration choice. Specifically, you'll provide these certs through Kubernetes secrets. If you're using a publicly trusted CA, then you don't need the private CA option. The Helm install process will kick off the Rancher installation, but you'll need to perform the steps in the following demos for Rancher to actually start serving traffic.
After installing Rancher and telling it to use private CA certificates, we now need to create the TLS secret in the Kubernetes cluster and populate it with the certificate data. To do this, first create a file on your local system called tls.crt with the certificate. Next, create another file called tls.key with the private key. Finally, create a secret called tls-rancher-ingress from those files. This secret is of type TLS.
I've generated my own private key infrastructure, or PKI, in this clusters folder. The server certificate is issued by my own self-signed CA, seen here. I have to create a Kubernetes TLS secret with a specific name for Rancher to use these certs when serving its HTTPS traffic.
And if you're using a private CA, you'll create a generic secret in the cluster and populate it with the CA data. On your local machine, create a file called cacerts.pem with the private CA information. From the same machine, create a secret called tls-ca from this file. This secret is of the type generic.
A private CA is optional when using your own certs. I've generated one in my PKI to give a complete example, but you can skip this step if it doesn't apply. However, if you're using a private CA like this one, then you'll need to create a generic Kubernetes secret with a specific key and the certificate in the value. Here I'm using a local file with a different name from the secret's key, so I've used a syntax that specifies both a key name and a local file. Now I can inspect the Rancher deployment and see that it's up and running. When I access the server in my browser, I can see it's using my server cert issued by my CA. I see this warning because my machine doesn't trust my CA. Ideally, this wouldn't be the case when using a private CA.